Welcome my friends and students, family. In this video, I'm gonna show you a crucial fundamental, okay? Of electrical engineering. So this crucial fundamental is about series and parallel resistances. So this fundamental is crucial because this the fundamental of series and parallel resistances has a very crucial application for the design and analyze for the design and the analyzing analyzation of electrical circuits. So resistances can be in analog design, can be put into series and parallel. So series, that means that resistors are connected, resistors or resistances are connected in end to end. So we can call them R1, R2, and R3. That means that each one of them is a resistor in a resistor circuit, resistor circuit. Later you're gonna learn that resistances can be analyzed for other kinds of devices and different types of circuits. So parallel is, so here's we're going from end to end. So what do you think parallel would be? Parallel, if you remember in mathematics, two parallel lines are two lines that don't touch each other, but they are 90 degrees of each other, opposite of each other. So here's 90 degrees, here's 90 degrees. That means that they never touch. So that's what you learn in that we learn in mathematics. But it turns out that in parallel circuits, it's something similar, but that being touched is not really what we meant by that. What we meant is that we have a node here and a node here, and from that node there are different paths. So this is R1, R2, and R3. As you can see, there is one, so all these resistors are connected in one node. The node is here. You can see here there are different paths. Here current flows in one direction. Here current gets divided into three paths. And how much current will depend on the resistance, the resistor value, resistance value. And resistors or resistance is denoted with the Greek letter omega. So this could be 5 ohm, 10 ohm, 15 ohm. Same thing over there. But there is a difference between how current flows, like I said, on a series circuit and in a parallel circuit. And how voltage also, how voltage flows, not how voltage flows, current flows, okay, current flows, but voltage, how voltage behaves across each resistor. In this case, from here to here, from here to here, here to here, or from here to here, from here to here, from here to here. So keep this in your mind. These basic models for resistors, for resistances, because you're gonna use them. Okay, so I'm gonna write three things about each type of circuit. So for series, the current is equal for each resistor. Voltage is different, or is not necessarily the same for all resistors. Also, to compute the total resistance, so R total, what we do is we sum each resistance in the circuit, in the series circuit. Parallel is a little different. For parallel, current is divided, as I said before, is divided for each path. Voltage is the same across all resistances. And then for the R total, it's a little different. So the way it's done is as follows. So 1 over R total is equal to 1 over R1 plus 1 over R2 all the way to the last resistance. And then if you want to find the R total, what you do is you take the opposite of this. You take the reciprocal. So R total is equal to 1 over R1, R2, all the way to Rn. And I suggest you do this one first and then take the reciprocal once you have the sum when you're given each resistance. So now let's look at one example for each case. So for series, let's see. Let's say you're given 4 ohm, 6 ohm, and 10 ohm in series. How would you calculate the total resistance? The total, our total, would be 4 ohm plus 6 ohm plus 10 ohm. And what does that equal? 4 plus 6, 10. 10 plus 10, 20 ohm. What do you guys think? You can find different, you can test yourself by choosing different resistance values and add them up. You get that R total. Now let's look at one parallel. How you would compute it. Let's see. Let's say you're given 5 ohm, 10 ohm, and 20 ohm in parallel. Okay, so how I would do it and you would do it as follows. So 1 over R total is equal to 1 over 5 ohm plus 1 over 10 ohm plus 1 over 20 ohm. Now, like I said, if you want to find the total resistance, you do the reciprocal. But in these cases, we have the value for each resistance. I would do this first, like I said. So what's okay, so let's do this one. 1 over 5. What's 1 over 5? That's Okay. Okay. To make it more, I'll do it in two parts. First, our 1 over R total is equal to 1 over 5, which is 0.2 ohms, 1 over 10, which is 0.1 ohms, and 1 over 20, which is 0.05 ohms. And that whole thing is equal to 0.35 ohms. So what did I tell you? The next step, once you have this, that's 1 over R total. So to find R total, what you do is this: R total is equal to 1 over 0.35 ohms, and that's equal to approximately 2.857 ohms. So that will be the final answer we will be looking for. What do you guys think? So you can see parallel is a little more involved, but because of the structure of the circuit. But in reality, we're talking about resistances, so the concept of resistance is still the same. So I'm gonna end up this lesson by saying 3 applications of series and parallel resistances. So the first application is power management, for power management. In power management, what I'm trying to relate series and parallel resistance is that we need to, for each electronic device we create, we need to ensure that proper current and voltages are applied. To each device. Second, signal processing. We use this concept when we're trying to tune a circuit to respond to certain frequencies. You're gonna see this when you're doing filters and other stuff related to this. Okay. And the third one is when we have when we're talking about circuit safety. We use this concept of series and parallel resistance when we want to avoiding circuit overloads. By calculating expected resistance. So using this basic concept, you should be able to, just by using what I just taught you today, you should be able to, once you grasp this concept, you should be able to do a lot of things already. Of course, electrical engineering and computer engineering builds up on these concepts. So I suggest you pay attention to these things because you're gonna see it everywhere when you're designing and analyzing circuits, analog circuits, and even digital design. Because in digital design, when you're talking about electronic devices, like in the past when I was starting to learn these type of things, MOSFETs, you're gonna see resistances as well. So you should. This is a very crucial concept for you to learn. So thank you very much. Don't forget to subscribe. I really appreciate your help and support. Thank you.